Hello everyone, welcome to my channel. In this video we are going to learn about circular queue in the queue data structure. Circular queue is a linear data structure in which the operations are performed based on a FIFO rule. That is the first in first out rule, and the last portion is connected back to the first portion to make a circle. Okay, so circular queue also performs the same operations that are performed by the normal queue. Okay, so here the only difference is, so we are going to connect the end of the queue to the starting of the queue. Okay, so this is the queue with number of partitions. So this is the end of the queue and the starting of the queue. So we are going to connect back the end of the queue to the starting of the queue, so that it will make a circular queue. Okay, so what is the need of the circular queue here? Why we are going to the circular queue? So we can perform the insertion and deletion operations only in the normal queue only, right? So what is the importance of the circular queue? So normally in the case of the normal queue, so when we perform the delete operations through the front pointer, right? So when we perform the deletion operations through the front pointer, then so this is the front pointer, right? So here the rear is pointing to the end of the queue. So here this is the front pointer. So when we perform deletions using the front pointer, so it will start deleting the data in the queue, right? So next we are going to increment the front pointer. So next the front pointer is pointing to the next one. So we will delete the next one also. So here in the given queue, 2 memory locations are free. Okay, so even though 2 memory locations are free, if you want to insert a data item, we cannot insert it into the queue because the rear is pointing to the end of the queue, so it cannot insert. If you want to insert a data item, we need to increment the rear pointer, but so rear is at the end of the queue. Okay, so even though there is the memory is logically deleted here, so we cannot use this memory in the case of the normal queue. So that's why we are connecting the end of the queue to the starting of the queue. Okay, so now the rear can increment to the starting of the queue and we can insert the data into the queue. Okay, so here using the circular queue, we are using the unused memory space in the queue. Okay, so this is the main benefit of the circular queue. So similar to the normal queue, here also we are going to perform the insertion and deletion operations, that is the NQ and DQ operations using the circular queue. So to perform the NQ and DQ operations here, so we are having a formula. Okay, that is rear equals to rear plus 1 modulus n. Okay, so rear equals to rear plus 1 modulus n. So this is the formula to insert a data item. Okay, and similarly if you want to perform the deletion on a data item, then front equals to front plus 1 modulus n. So this is the formula for the deletion operation. So now let us see how can we implement this formula on the circular queue. Okay, right, so we will see it using the program here. So now let us see how can we apply this formula on a circular queue. So we are considering a circular queue with 3 memory locations, that is 0, 1 and 2. So initially the front and rear are the -1 position. Front and rear are equals to -1. Okay, so now let us apply this formula. So first of all we are going to perform the insertion operation and increment the rear pointer. Okay, so initially the rear is at the -1. So if you want to insert the data, just insert the value of rear into this formula. So rear equals to -1 plus 1 mod n. So -1 plus 1 is 0. So 0 mod n is 0. So that's why R will point to the 0th location and will insert the data item, that is 1 here. Okay. So next, again we are going to insert the data. Okay, again apply the same formula. R equals to 0 plus 1 mod n. So 0 plus 1 means 1 mod n. So here n is the size of the circular cube. Okay. So what is the size of the circular cube here? 3, right? So 1 mod 3. So 0 plus 1 modulus 3. That means 1 mod 3. So 1 mod 3 equals to 1. So now R will increment to the next location, that is the 1. Okay. So here data will be inserted, that is 2. Okay. So now again I want to insert the data into the circular cube. So we will apply the formula R equals to R plus 1 modulus n. Okay. So R is at the location 1. So 1 plus 1 modulus n, that is the size of circular cube, is 3. So 2 modulus 3. So 2 modulus 3 is 2. So R will get incremented and it will point to the next location, and we can insert the data here, that is 3. Right. So now, we have inserted the data into the circular cube. So now we need to delete the data from the circular cube by incrementing the circular, by incrementing the front. Okay. So now front is at the -1 position. So if you if you substitute the value here, -1 plus 1 mod n, that is 0, right? -1 plus 1 is 0. So 0 mod n is 0 mod 3 is 0. So front will get incremented and it will point to the location 0. Okay. Okay. So now, we need to delete the data here. Okay. So after pointing it, we are going to delete the data. So we will delete the data in the queue. So now again we need to increment the front pointer. Okay. So now front is at the position 0. 0 plus 1 mod n, that is 1 mod 3. So 1 mod 3 means the front will point to the next location, that is the first index. So front will get incremented here. So the data is deleted in the 0th position and it will increment. Okay. So now again we need to substitute this formula. So after deleting the data here in the first location, so that 2 will get deleted here. Okay. So now again we need to apply this formula. So 1 plus 1 mod n. So 2 mod 3 is 2. So now again front pointer will point to the next location, that is the second location. So it will point to the second location. Okay. And the data here will also get deleted. Okay. The front pointer data will also get deleted. Okay. So again we need to apply the same formula. So front is at the position 2. Okay. So 2 plus 1 mod n. 3 mod n means 3 mod 3 means 0. So again the front will increment to the next pointer. So like in this fashion, so we are going to increment the front and the rear pointer, and we can perform the insertion and deletion operations. Okay. So now we will see how can we perform the insert NQ operation on the circular cube. Okay. So we will consider this formula in the NQ operation. The rear equals to rear plus 1 mod n. Right. So here we are having certain conditions. So if you want to insert the data into the queue, first of all we need to check whether the queue is full or not. That means queue is whether the insertion is possible or not in the queue. So that means whether the queue is undergoing overflow or not. Okay. So for that we are having a if condition here. If front equals to 0 and the rear equals to size minus 1. Okay. So we are considering the size of the circular queue as 3. Right. So if the front equals to 0, that means front is at the 0th position. That means there is no deletion performed. And the rear equals to size minus 1. That means rear is at the last position of the circular cube. That is, rear is pointing to the second location. Or front equals to rear plus 1. So in these conditions, so the circular queue is full and we cannot delete the, we cannot insert the data into the circular queue. Right. So how we can perform this, we will see here. Okay. So first, so we are going to initially the front and rear pointers will be equals to -1. Okay. So now we'll check whether the front equals to, so here we'll check front equals to 0, rear equals to size minus 1 and front equals to rear plus 1. So this condition is not possible. So we will go to the else part. So we will go to the else part and we can insert the data into the circular cube. Okay, so now rear is at the position minus 1. So minus 1 plus 1 is 0. So 0 mod n, that is 0 mod 3 is 0. Okay, so now rear pointer will get incremented here and it will point to the 0th location. Now the rear pointer will move to the 0th location here, right? So now printf enter an item. So we are going to insert the item 1. Okay, and then q of rear equals to item. So here the q of rear equals to that particular item. So here the item is inserted here. Now insertion is successful and next we are going to check the condition. If front equals to minus 1, make it as front equals to 0. Now front is at the minus 1 position. So we have to move it to the 0th location. Okay. So now front and rear are pointing to the same location. Right. So front and rear are pointing to the same location. So now again we will execute the code. So here the if condition will fail and we will go to the else part. So rear equals to rear plus 1 mod n. So rear is 0. So 0 plus 1 mod n. That is 1. Right. 1 mod 3 is 1. So now rear will increment to the next one. So rear is incremented to the next one. And we can insert the data here. So enter the item. So we are inserting the data 2. Okay. So now rear has incremented here. Right. So now again we are going to see the q of rear equals to item. So the rear is pointing to the particular item 2. Insertion is successful and if part is skipped here because front is at the 0. Okay. So now again we will execute this code. So now we will go to the else part. So in the else part, rear equals to rear plus 1. That is 1 plus 1 mod 3. 2 mod 3 is, so 2 mod 3 is 2. So rear will point to the next location. So 2. So here data is inserted here. That is 3. So q of rear equals to item. That is 3. Okay. So now we have inserted the data into the queue. Now we need to perform the deletion operation. So if you check the if condition, front equals to 0 and rear equals to size minus 1. So this condition is satisfied here, right? Front equals to 0 and rear equals to size minus 1. That is size is 3, right? 3 minus 1 is 2. So rear equals to 2 and front equals to 0. So in this type of scenario, we cannot insert the data into the circular queue, right? We cannot insert the data into the circular queue. So now we are going to perform the deletion operation from the using the front. Okay. So after performing the deletion operation, okay, so this is the first scenario. So in this, this scenario we will see front equals to rear plus 1. Okay. So now, so we are going to increment the front pointer to the this location, first location, and the data is there is no data available in the front pointer, right? So there is no data available in the front pointer. So now again we will apply the formula rear equals to rear plus 1 mod n. That is 2 plus 1 mod 3. That is 3 mod 3 is 0. So now rear will point to the 0th location and we can insert the data here, that is 4. Right? So now, so we can see that this condition is satisfied. So front equals to rear plus 1. That is front value is after the rear, right? Front equals to rear plus 1. So this condition is satisfied. So in this type of scenario also the queue is full, right? These are the two scenarios where the queue is full. Okay. So in this type of scenario we cannot insert the data into the circular queue. Okay. So now we will see the deletion operation on the circular queue. Okay. So in the case of the deletion operation, so here the if front equals to minus 1, that means there is, so front equals to minus 1 means there is no data in the circular queue. So we cannot perform the deletion operation on the circular queue, right? So initially the front and rear will be at the -1 position, right? Front comma rear equals to -1, right? So in this type of scenario, so we cannot perform the deletion operation. Okay. So after inserting the data into the circular queue, so now we are going to insert the data into the circular queue. Okay. If we insert the data here, 1, the rear pointer will point to this location. Okay. And again we are going to insert the data here, rear plus 1 model, right? So 2. And then again we are going to insert the data into the circular queue, that is 3. So rear will point to the second location here. Okay. So now front is at -1 position. So we are going to increment the front using the front plus 1 model, right? So front will get incremented here. Okay. So front will get incremented here, right? So front will point to the 0th location. So now we are going to delete the data in the 0th location. Now front will increase the pointer here. Okay. So it points to the first location and it will delete the data here. And again front will point to the second location. So now this condition is met else if front equals to rear. That means, so here there is no data available here, right? Okay, so front has performed the deletion operation on the 0th location and first location. That means there is no data here in the first location and 0th location, right? So there is data available only at the particular location, that is the second location. So now front equals to rear. So this type of case will occur when there is only one element in the circular queue. Okay. So when there is only one element available in the circular queue. So front equals to rear. So now, so we are going to perform the deletion operation. Deleted element is, so we are going to delete the element in this location and make front equals to -1 and rear equals to -1. So we are going to make it as front and rear again as -1. Okay, in this type of scenario. Okay, else printf deleted element is %d comma q of front. So this condition will occur in the case if there are more elements available. So if there is single element available in circular queue, front equals to rear will occur. If there are more elements to perform deletion, then this type of condition will occur. Okay, so simply by performing the front equals to front plus 1 model. So we are going to increment the pointer and delete the items in the circular queue. So this is how we are going to implement the circular queue in the queue data structure. Thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.